Warm greetings, friends, and my dear students. Today we are going to see the video lecture on the composite section bars or compound bars, which are subjected to the load, and the load is carried by the different section of the material. For example, one steel bar and two copper bars. So, what will be the load carrying capacity of these compound bars, and how to find the stresses induced in the steel and the copper material, and what will be the deformation of the steel and the copper material. So this will be defined by today's lecture. For example, I have taken the bars of composite section like this. You can see that the load is applied is capital P, and the corresponding length of steel and copper bars as shown in the diagrams are LS and LC. I introduced the two copper bars and one steel bar. The area of the corresponding steel and copper bars are AS and AC. The case of the area of a copper bar, we have to multiply by the 2. So if it is a solid circular bar, 2 into pi d square by 4. Similarly, you can calculate the corresponding the steel area. So after that, we have to apply the two conditions for the composite section of the bar, either to find the unknown stresses sigma s and sigma c, which are introduced in the steel and the copper bars of the material, and also the Young's modulus value of steel is capital ES and Young's modulus of the copper is capital EC. You know this area of the cross section of the bar, so it will be given. So we have to apply the two conditions. So what are the two conditions to apply the design load or the stresses in the two material or the deformation of the given material? The first condition is the total load applied is equal to the summation of the load taken by the steel plus the load taken by the copper bars. So that is equal to sigma s into AS plus sigma c into AC. Sigma s and sigma c are the stresses induced in the steel and copper respectively. AS and AC are the corresponding area of the given steel and copper bar. So from this we can find the unknown value of stresses if the load is given. And after that, the second condition for the compound bar, which is of a different length of the bars which will carry the load, is here the change in deformation or change in length of steel bar is equal to the change in length of the copper bar. So delta LS is equal to delta LC. You know that delta LS is equal to sigma S by ES into LS, which is equal to sigma C by EC into LC, where sigma S and LS, you know, the stress and the corresponding length of the steel bar, and ES is the Young's modulus of the steel bar. Similarly, sigma C and LC are the corresponding stresses induced in the copper and the length of the copper bar. And capital EC is equal to the Young's modulus of the copper material. If we want to find the corresponding value of the stresses sigma S or sigma C, for example, I am finding the sigma S, we can put ES by EC into LC by LS into sigma C. So once you know sigma s, you can find the other value of sigma c, or the deformation can be determined. Suppose I want to find the delta ls or delta lc. You know that the Young's modulus of steel into the length of steel. So Young's modulus can be replaced by, strain will be replaced by stress by Young's modulus. So from that equation you can find the deformation of either steel bar or copper bar. So these are the two known conditions you can able to solve the corresponding stresses, deformation, or the stresses is given, you can find the load carrying capacity of the compound bars. Either you can find delta ls first or delta lc after that. So from that you can find the any unknown factors in the case of compound bars which are of different sections. If the load carrying capacity is not given, the stresses will be given sigma s and sigma c, and already the lengths of steel and copper are known. So we can able to find the corresponding value of the deformation of steel and copper material respectively. So this is about the design of the compound bar which are of different length, or you can find the stresses in steel and the other material. Here I have taken the copper material. So you can able to find the sigma s and the sigma c. From that you can able to find the corresponding value of the deformation of the steel and copper material. So delta ls and delta lc. So if delta ls is equal to delta lc, then only the stability of or the equilibrium condition will be exist. Otherwise what will happen, the instability of the load will be taken place, so that the compound bar will fail due to the instability. So that is very much important. That's why so delta ls is equal to delta lc here. So definitely if delta ls is not equal to delta lc, the stability will not be there, the compound bar will fail. So we can see in the next video lecture about some case study of the compound section of the bar. If the length of steel and copper or two material are equal, or it is of uh, different dimensions. Thank you very much for patient listening. வாழ்க வையகம், வாழ்க வளமுடன். Goodbye. Thank you.